Hello guys, Namanjot Singh this side from NetClass again. In this video, we will discuss about network layer. So as we discuss about the transport layer helps in multiplexing the connection and setting up and maintaining the connection. It helps in flow control. It helps in error detection as well by sending acknowledgement packets. And it helps us other, like it has a different concept like port number and all. TCP, transmission control protocols, comes under this transport layer, and user datagram protocol comes under the transport layer. TCP is reliable and UDP is the unreliable connection. You can watch this video on the transport layer. So now let's discuss about the network layer. Now we have a data that is distributed into small portions, and this data is called, in PDU, protocol data unit, is called segment. Now we have a segment in the network layer. What network layer do with this segment and what would be the use of it? Let's dive into it and let's discuss about it. Okay, so as we discussed previously about the layer 3, that is, this is my favorite layer by the way, the network layer. So now we have segment at network layer. So what happens is we have a PDU that is called segment. We have small data. Now network layer will add its PDU, protocol data unit, towards its header, and now we will call this a packet. We have a packet in the network layer. So what network layer is responsible for? It helps in logical addressing. What logical addressing is? So logical addressing means IP address and all. If you have watched my previous video, you would have known there are two types of addresses, logical and the physical, of a node. A node is a computer. A logical identity of a node is IP address, and physical identity of a node is MAC address, media access control. So these two are very necessary when forwarding the traffic. So network layer helps in logical addresses of the network, and it helps in finding the best path. Let's take the example of this network we have. Okay, suppose this is a network and we have some router here that is connected, and we have a PC connected to this. So this is a remote branch. So what happens is, let's say we have all this interconnected and we are having a lot of routers connected with it. Okay, let's take the example of this. We have router 1, router 2, router 3. When I'm talking about the internet, this is a very good analogy of an internet, and all these routers are connected. We are sending packet from node A to node B. How this follows this best path depends upon the decision we made. How this decisions comes from? This decision is made with the help of transport layer. Okay, with the help of transport layer, the decision is made. So this is the reason it helps in finding the best path to forward the traffic. Okay, so let's see this. In network layer, it comes IP addresses, which helps in forwarding the traffic. What IP address is? I have a separate video I have made on the IP addresses. You can have a look in the I button here, and in video description I have added the link of that video as well. That is a very detailed conversation about the IP address, how IP address is made, how we can make IP addresses, about subnetting and all. I will make one more video about the subnetting and the gateway as well, and I will put that video link in the I button in the description as well. You can watch these two videos in sequence, first the IP addresses, then the subnetting and the gateway part. It will be very beneficial for you to understand it. So let's take an example with IP addresses. You can watch this video to have a detailed example. For example, we are having this PC, right? We go to command prompt and we write a command that is ipconfig. This IP config give us some details. What this detail is? The detail is the IP address, the MAC address, and the subnet and the gateway. So this IP address is addressed at this network layer. For example, we have an IP address of 192.168.100.1. This is one IP address. Please go and watch that video. And there is another 192.168.100.2. These IPs are in same network. In this way, they both can communicate with each other. This is the concept between the logical addressing. So we have subnets as well. These both IPs need to be in the same subnet to make them communicate with each other. At network layer, we have one more protocol that is very necessary, that is called ARP. ARP stands for Address Resolution Protocol. What does this ARP stand for? It stands for Address Resolution Protocol. What it does it? For example, you have a network. You know the IP address of this PC. There is a remote node. You know the IP address, but you don't know the MAC address. But MAC address is necessary to send the packet. So what router will do is, router will broadcast a certain packet and it will get a reply from all the nodes with the MAC address. Whoever is having this IP address will reply with MAC address. So we help in maintaining routing tables. This routing tables decides what is the best path, how we can send the packet, if there should not be any loop in the packet. So this is how things work. Similarly, so what ARP is, Address Resolution Protocol, it resolution. So means IP to MAC address is ARP. So same we have another protocol that is RARP. What R stands for? It reverse. So reverse, Address Resolution Protocol. As the name suggests, it is from the MAC address to the IP. If we have the MAC address of a node and we want to know the IP address of a node, we will forward a broadcast message and whoever having a MAC address will reply back with a certain IP address that we need. So this is how networks layer work. Network layer have IP, right? IP addressing. IP addressing is an unreliable kind of connection. At network layer, we make unreliable kind of connection when we are discussing about IP addresses. But how reliability is maintained if we want to maintain a reliable connection? So at network layer, we will use a protocol named IP addresses, TCP/IP, Transmission Control Protocol, Internet Protocol. But at the transport layer, at a one layer up, we will use reliable connection. That is again, as discussed about the previous video, TCP, Transmission Control Protocol method. Yes, reliability and unreliability, flow control. So at transport layer, we will use reliability or the unreliability kind of connection, and the TC and the network layer, we will use IP addresses, that is reliable connection. There are other protocols in network layer as well. For instance, DNS, DHCP. Let's discuss about these in short. We will be making different videos on this. This is a very complex topic and we will see this in quite details in the next videos. So DNS means domain name server. For example, you type 8.8.8.8, it is google.com. So let's open, let's say we are opening our internet and we are typing here 8.8.8.8.8. So this will open google.com. Why? Because we are not very good at remembering the IP addresses, but technology has done a favor for us. Now we can remember the names. So what this do is, it will resolve the name, but at the back end IP addresses work. We are just remembering the name. So domain name server, that is just doing a job for us to consolidate for us the IP addresses. We can type google.com, either we can type 8.8.8.8. It is the same thing. So DNS works like this. Same is the case with DHCP, but DHCP, Dynamic Host Configuration Protocol, is the full form of this. For example, you just on your PC and you connect it to internet and you get an IP address. how we maintain this IP address, how we get this IP address. Nobody is giving to us, right? This we got from the dynamic host configuration protocol. With the automatic dynamic host configuration protocol, we are automatically getting the IP addresses. So in DHCP messages, we will discuss in future videos. So this is all about the network layer. We have discussed in detail about the IP addresses. You can check the videos in the I description and the video description as well. Let's give it a 5-6 minutes about the IP addresses just to make a quick revision. IP address is 4 octets, 32-bit, and 1 octet is 8-bit long. What is a bit? It is either a 0 or 1. So 4 octets, 1, 2, 3, 4. When we say 1, 1, 1, 1, 1, 1, 1, 1, 8 times, how many bits we are using? 32 bits. How many octets are there? 1, 2, 3, 4. We are saying it's a 4 octets, each having a 8 bit. So maximum value is 255. As you know, you would have studied about in the binary to decimal and decimal to binary conversion in the primary class. 2, 3, 4, 5, 6, 7, 8. This is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 4, 5, 6, 7. 2 raised to power 7 is 128. 2 raised to power 6 is 64. 2 raised to power 5 is 32. 2 raised to power 4 is 16. 2 raised to power 3 is 8. 2 raised to power 2 is 4. 2 raised to power 1 is 2. And 2 raised to power 0 is 1. So you add all this comes to 255. So IP address is having a maximum value of 255. So at a clock, when it clicks 359, it doesn't say 360, it straight say 4. Same is the case with IP addresses. There is no 256. At 255 there comes 1 only. So when we are saying our IP address is 192, we are saying let's convert 192 in the form of binary language. 2 4 2 8 is 16, 2 6 is 12, the carry is 0. 18, sorry, 9 2 is 18 and 6, 2 4 is 8, 2 8 is 16, 0, 2 2 is 4, 2 4 is 8, remainder is again 0, 2 1 is 2, 2 2 is 2, remainder is again 0, 2 6 is 12, remainder is again 0, 2 3 is 6, remainder is again 1, and 2 1s is 2, remainder is 1. So going from here to here, 1 1 0 0 0 0 0 0, 1 2 3 4 5 6, 1 2 3 4 5 6. So these two values are 1, all other are 0. So we would say 128 plus 64. What is 128 plus 64? It is 192, guys. So the IP address is 192, the first octet, and then similar we can convert other octets as well. So this is how IP addresses work. In IP addresses we have subnet as well. Subnets decides the IP addresses should be in the same subnet to communicate with each other. The concept behind this is you need to be in the same house to talk with someone, right? You can't understand from the neighbor if you are not shouting with a high volume enough. So same way subnet works. So other concept is default gateway. What is the default gateway? The exit door of your house. When you want to go from this house to the neighbor house, you will take a exit way. That is a door outside. So that door outside is the gateway address. Okay, so see this. This is the gateway address, the exiting address of the IP. This is the subnet which decides that all the IPs are in the same subnet, and this is the IPv4. This says that it is having a certain logical IP. So this is how network layer works, guys. And once again I would like to mention that please go through the video of network layer. We have discussed that in very detail about the IP addresses, and we will discuss about the subnet and the default gateway as well, the classes of IP address. That is a very big concept. But in this series as well. After completing data link and the physical layer, I will definitely touch the IP addresses, the conversion, and how things work in a one big video also. So let's stay tuned for the next videos for this whole course. And please like this video and subscribe the channel from the net class. We are working so hard to bring the best content forward. Thank you so much, guys.